grief. Well, evidently after 4 tries at this, I was able to do this on the fourth one. So if you've, so for 8th grade, those of you who are with me here, see the 3 other choices of me trying to go live, you'll see that I've now, well, I'm here. So yeah, having fun with this, having fun with YouTube this morning. It's good stuff. Good stuff. All right. Hopefully everybody's good. I'll give a second here and then I get started. Good my gosh. Gotta love it. Gotta love the technology. I like technology too. I mean, I like technology. It's the way of the future, right? All right. Make sure we're good. Make sure we're good. I want to get into some things. As you guys kind of come into here, as you guys kind of come in, I'm going to tell you a little story about YouTube here for a second. But in one of my videos from yesterday, I was showing like utilizing the Pearson, the Pearson stuff that we've been doing throughout the year. And they had a video on there, and evidently the YouTube algorithms decided to flag the little 10 seconds of, I guess, some classical waltz was used within that video. And so evidently the algorithm picked that up and put a copyright claim against the video. So anything that we were working with yesterday with that, yeah, I'm not going to take the chance. I'm not taking the chance of playing any type of media or any type of that stuff, because I'm not gonna take the chance of getting a YouTube channel some stupid stuff happen to that. So with that being said, if you take a look, those of you live with me or on demand want to take a look at Google Classroom, obviously classroom.google.com. Thought I was in there, but I guess not. Classroom.google.com. I have to bring up mine. Let me add my other one quick. I had to sign out of everything because every time I was trying to go live, it would sit there and it would. Every time I was trying to go live, it would tell me, "Oh well, oh, live streaming isn't available," and it's like, well, what the heck? So anyway, so if you were to click on one of your classes, whatever it would be here, you'll see that now I have this pinned to the top of the stream there. So it's pinned to the top of the stream for you guys to reference. If you guys had it downloaded, if somehow it was printed out and given to you, I don't know. Depends on however you obtained your thing here. But for you guys for the 8th grade, the 8th grade packet, that's what we're going to deal with. I'm going to try to get through some of it. I can't guarantee getting through it all, obviously, because there's a lot to go over. But it's just to kind of reiterate and kind of at least keep it somewhat fresh in the mind for you guys if you guys had had kind of went through that. So, anyways, let's get right into this. If you remember, if you open this up, these packets are broken down. Your curriculum is broken down into 8 sections. So there's 8 sections that you have that the curriculum is broken down into. So in the instance of today, I'm going to be talking about topic 6. So topic 6, take the ride down the side here. So again, if you heard my story about, that was my first ever real instance with YouTube algorithms. It's fun stuff. They ain't no joke. I can tell you that. If they're looking at that, they'd be sitting there and taking a look at a channel that has 100 and something subscribers or whatever it is. A lot of this deals with similarity, congruence, all this stuff. If you remember dealing with all of the, I guess you would say the. Go. I think you guys remember all these good terminologies right here, dealing with alternate interior angles, seam side interior angles, corresponding angles, an exterior angle of a triangle. Now those we did not get to at the most. It was that was the next week before the world went crazy. these top three, we talk about alternate interior angles, same side interior, corresponding angles. Remember, I created those little handouts that had the two parallel lines broken by another line, as you see right there. If you remember, alternate interior angles, alternate interior angles. If you remember our vocab for this line right here, this line is called the transversal. Transversal. It transverses both parallel lines here. Transverse means travel. You know, that's for anybody who's into the the ELA of it and everything. So if you take a look right here, the idea of this is to be able to connect the two sides right here. So alternate interior angles. Well, do they lie on the same side of the transversal and in corresponding position? Remember, corresponding means the same. Corresponding would mean like the same. So if I had an angle that was 30 degrees and I was looking for another corresponding angle, corresponding means in that same position it has 30 degrees. Well, alternate interior angles. If I have an angle here, well, my alternate angle would be my angle on the other side, the alternate on the other side right there. So they lie within a pair of lines and on opposite sides of a transversal. So I would be connecting both that to that second stanza right there. Okay. So number two, if I have same side interior angles, well, again, they are interior. If they are interior, let me change this up right here. If they are interior, they're interior, know that they're within these two parallel lines right here. So if they are interior, okay, are they going to lie on the same side of the transversal and they are on the same side of the transversal. Let me actually get some of the writing off of here. I'm going to create a new pair of lines. New pair of lines. There we go. Good stuff. So interior means they're within the two parallel lines right here. So are they on the same side of the transversal? Yes, they are. But are they in corresponding positions? Well, no, because same side interior angles means they're on the same side. And as you see right here, this angle is shorter. This angle is less than the obtuse angle that you see right here. So when you look at your potential definitions right here, we know it's not this. We know it's not this. There are two adjacent interior angles corresponding to each exterior of a triangle. That has nothing to do with what we're talking about here. Number four is this: were formed by a side and an extension of an adjacent side of a triangle. Makes no sense. By taking a look at this, you can say same side interior is going to be lying within a pair of lines and on the same side of a transversal. So if you were connecting them, you connect two all the way down to where it says lying within a pair of lines on the same side of the transversal. Okay, that's number two. We'll change, make a new one. So if I have two lines like you see with the transversal, the corresponding angles, okay, lying on the same side of the transversal and in corresponding positions. If you were taking a test and you saw the word corresponding in both there and the definition, if you had no idea what corresponding positions are and everything. What's up, Malachi? Again, sorry about the 4 different feeds there, but YouTube must have been funny with me, so I can only deal with what I'm dealt with here. So I apologize, but yeah, we're into this stuff here. What's up, Brandon? How you doing, man? So on the same side of the transversal, remember this is your transversal, so on the same side of this and in corresponding positions. Corresponding means if I have two angles that are going to be the same. What's up, Joey? How you doing, man? So if you look at this here, well, it looks like people are finally getting the fourth different thing here. So those of you wanting to get kind of caught up right here, the alternate interior angles is going to be going with the line within a pair of lines on the opposite side of a transversal. Same side interior angles is going to be lying within a pair of lines. Corresponding angles is going to be lying on the same side of the transversal in corresponding positions. Now, an exterior angle of a triangle, it's exactly what it says. If I have a triangle here, all right, if I have a triangle and the exterior angle of a triangle is going to be formed by a side, and an extension of an adjacent side. Okay, there's your extension of the adjacent side right there. All right, I'm doing okay, Joey. How you doing, man? So there's your extension of the same side right there. All right, of an adjacent side of the triangle. Well, that exterior angle is this that you see right here. So if I have my triangle, like you see right here, so if I have my triangle, and there's my extension that you have right here, well, the angle that gets created is what you call an exterior angle of a triangle. And that's what that would be right there. That's what that would be right there. Okay. And just really by process of elimination, you can look at remote interior angles of a triangle are two adjacent interior angles corresponding to each exterior angle of a triangle. And we'll get so, and again. All right. Scroll down. This is everybody's favorite thing about translations and reflections and all that kind of good stuff. So remember, with the translation, I'm going to try my best to draw this here, kind of zoom in so I don't have to zoom. There we go. There we go. So if we were to draw this image, after a translation, 3 units to the left and 2 units up. The idea here, ladies and gentlemen, is to take each of your vertexes that you have right here, and when you translate something, that just means you're just moving it. It's like taking a piece on a game board. You're just moving it. You're not turning. You're not doing anything of that sort. Translation just means you're shifting it. Okay, it stays in the same direction, but you're shifting it. Okay, and for the sake of my drawing right here, you would take this trapezoid that you have right here, and you would go 2 units up. So it'd be 2 units up, and then 3 units to the left. And the new trapezoid should be something along the lines of 2 up, 1, 2, 3. So one of your things should be here. 2 up, 1, 2, 3, right here. 2 up, 1, 2, 3. 2 up, 1, 2, 3. And when you draw these together, you should see it as like so. Again, that's not. What's up, Raquel? How you doing? So when you do that translation, 2 up, 3 to the left, you should have something along those lines when it comes to that. Okay, should be something along those lines. All right. Hope that helps out a little bit. Let's keep moving here. So if you remember with reflective figures are the same distance from the line of reflection. I think we did the kissing Homer picture. It was the kissing Homer picture where it reflected, or it was the handsome Squidward where it was looking across the water. Who did that? Did that really good. they're really good. The top of the head, and then it come across to the bottom. It was a really good, it's a really good picture. So when you look at this, and you look at the reflection, all right. So in this instance, we look at number one and say, well, what are the coordinates of the image of the rectangle W, X, Y, Z after a reflection across the X-axis? X-axis, obviously, is the one that goes left to right here. So if I was reflecting it across the X-axis, so the new figure would be somewhere up here, right? Because it would be reflecting upwards. It's like looking in a mirror, reflecting it upwards. Now, just for the sake, I don't have this totally down right here, but the new figure should be something along the lines of up here. So the idea, what it's trying to tell you, what the question is really saying, well, point W is at -4 and then down -2. X would be -1, down -2. Y is -1, down -4, and then Z is over -4 and then down -4. And then when you're flipping these across, they're going to maintain the same X coordinate but a flipped Y coordinate. So the new figure, so your new figure in this instance, I'm going to go to the left. Change the color. There you go. So like remember I would say W prime. W prime would keep that same -4, but instead it would go up to X. X prime would be -1 and then up to. Y prime would be -1 and then up 4. And then Z prime would be -4 and then it would be up 4. Again, remember these, when you're reflecting across the x-axis, they maintain the same x coordinate, but the flipped or the opposite y coordinate on that. Okay. Just trying to get through as much as possible here. I hope that makes a little bit of sense. Here. Well, like in this, if I say, well, what's the coordinates of the image of this after a reflection across the y-axis? Instead of, so they would maintain the same y-coordinate this time. So if we were reflecting across the y-axis, they would maintain the same y-coordinate, but a flipped x-coordinate. It would be a flipped x. It was a flipped x, same y. Same x, flipped y. All right, that's kind of a way to be able to say that right there. All right, let's keep moving here. Couple more. I'm going to go down to the transformation. So the transformation right here. Again, these are like how we were doing the creating the emojis. You remember doing the emojis and all that good stuff. I mean, that's what this is kind of referencing here. So if I were to translate, so if I translate rectangle ABCD 5 units down and then reflect it across the y-axis, first thing you want to do, is you want to take ABCD. So if I take ABCD and we want to translate it 5 down. So if I start with A, I go down 1, 2, 3, 4, 5. I know that my new A would be here, my new B would be here, and since it's a 2 unit difference, I know that I can draw my 2 units here. So that's the translation. That's the translation of 5 units down. And then if I want to reflect it across the y-axis, remember here's your y-axis. If I'm flipping it over the y-axis, you know that these two vertexes here are 1 unit from the y-axis. So if I want to draw the mirror image, I would do that. and it's a 4-unit difference here. So 1, 2, 3, 4, down, over, and there. And right here would be that full translation in that instance. Your full translation would be the pink image that you see right here. After you translate it 5 units down and then reflect it across the y-axis, that would be the way you would do the transformation. Remember, transformations are multiple. They're um, multiple things you could do. If you were to do a reflection across an axis and then rotate it and then translate it, that's doing what we call a transformation. Okay. Um, with that being said, I hope you guys are having a good, hope you guys are staying safe, having a good week right there. If you have any questions with anything, please just reach out. Always reach out. Send me an email. Reach out in Google Classroom. Anything going on, let me know. Happy to answer any questions. I appreciate you guys. Hanging with me with some of that stuff going on there. And I just, like I said, I hope you guys are staying safe. With that being said, I'll let you guys be here. Take care. I hope to talk to you guys soon.